Hello, this is Ms. DB, and today we're going to talk about one of my favorite subjects in Chapter 2, and that is algebraic proof. So for those of you who miss having algebra class, I'm sure there's some of you out there, you'll enjoy this one because we're going to solve some equations, and as we solve them, we will explain what properties we're using that allow us to do the steps that we've all learned how to do. So this again is Chapter 2, Section 5. We will review the properties of equality and use them to write algebraic proof and identify properties of equality. You should definitely read through these pages in your book on this section, 104 to 107, for more examples and more thorough explanations. So here is the definition of proof is a logical argument that shows a conclusion is true. So we've talked about how to prove that your conjecture is false with a counterexample, but now we're going to look at how to prove something true using what we call a proof. We're going to start out with algebraic proofs, and then we're going to move into, for the rest of the chapter, geometric proofs. And we will practice doing proofs each chapter, a little bit each chapter to kind of keep you fresh. So a proof is how you are going to argue your case for something being true. And we will use properties like today, and we'll also use postulates, theorems, and definitions when we explain why we're able to do what we do in a proof. Here are the properties of equality that you have been using for a long time. The addition property says that you can add the same number to each side. Subtraction property says you can subtract the same number from each side. Multiplication and division is similar. The reflexive property says that a number is equal to itself, or a variable is equal to itself. Symmetric property says that if A equals B, then B equals A. We use this sometimes when we solve an equation and we get the n on the right side, like 2 equals n or 2 equals x, and we want to switch it around. You can do that by the reflexive property. The transitive property we will use a lot. That's very much like the law of syllogism that we learned about in the last couple sections ago. If A equals B and B equals C, then you can jump over the parts that are equal and just go to A equals C. And then substitution property, you've been doing this in algebra for a long time. If they give you a value of a variable and you plug it in, that's the substitution property. So we will use those, plus things like the distributive property. We might use the word simplify or combine like terms as justifications for our steps. All right, here's some more information about the reflexive property, the symmetric property, the transitive, and the substitution. So those are on your worksheet. Read those for a little bit more in-depth explanation of each of those. Then for 1 through 5, you have to go back up and find which property do the following situations describe. There's a couple that would be more than one. So let's look at the reflections of clouds on a still pond. So you probably would call that a reflexive property, but some people call that a symmetric property, and I can see that as well. Removing the quarterback of a football team and replacing him with another quarterback, that's like the substitution property. Adding 5 to both sides of an equation, this one's only got one answer. That is most definitely the addition property of equality. All right, so the full name is addition property of equality. If you just write addition property, I'll be okay with that. All right, so what we're going to do in these problems is you are going to solve the equation, and then on this side, you're going to write the justification. The first step in this one is given because we're just given that equation. Sometimes the first step might be using a property, like might be using the angle addition property or something like that. But in this case, our first step is just that that's our given equation. If you even want to write given equation, you can. And then we're going to solve the equation. And as we solve it over here, we will put the steps that allow us to do that. So the first thing that I would do to solve 3x plus 1 equals 13 is I would subtract 1 from both sides. So on this line, I'm just going to write that that's what I'm doing. And here you would write that this is the subtraction property And I'm going to use some abbreviations there and just write property of equality. Now on this step, I'm not really going to use another property. I'm just going to write what I would have left. And that would just be then to simplify. So all I did was I do the work. I'm going to call that simplify then. So that's not another property. Now my next step is that I'm going to divide both sides by 3. So I'm going to show my work here. And then over here I would write that this is the division property of equality. And then again I will simplify one more time, and then I will have my solution. And then this is going to be also to simplify. So that's how you solve the equations and write a justification for each step. Let's see if there's any that look a little bit tricky. On number 7, when you subtract x from both sides, because that would be the first step on this one. Let me return this a couple times so it is not on the split into 2 pages like that. So again, your first reason will be given equation, and here we're going to subtract x from both sides. That's the subtraction property of equality. It doesn't matter if you're subtracting a number or if you're subtracting a variable, it's still the subtraction property of equality. And then from there, my next step is just going to be that I'm going to simplify. Now you can either write 5 equals 1x, or you can write 5 equals x here. All I did was simplify that. And if you are one of those people who really like to have the x on the left side when you write your answer, then this last step would be the reflexive property. And again, it's of equality. Many of these properties have a sibling property for congruence, like there's a reflexive property of congruence. So that's why I'm writing of equality, because these are equal signs, not congruent signs. On this one, the first step will be the distributive property, and then you'll continue from there. It is possible to have, like you can see on this one, someone may not have done this last step, and I wouldn't mark it wrong because 5 equals x is the same as x equals 5. Some people would switch that, some people would leave it. So you may have 2 steps, you may have 3 steps, you may have 4 steps, depending on how much detail you put in your solving of your equations. Now the next part is when we are going to include some geometric figures in our proofs, and we're going to look at 2 types. We're going to look at when we use the angle addition property, or when we use congruent angles, or we'll work with segments. We might have congruent segments, and there's 2 things equal to each other, or we might use the segment addition postulate from chapter 1 that says that 2 parts are equal to a whole. So those are the different kinds of properties that we will work with in this worksheet. We'll do more geometric proofs, like I said, for the rest of the chapter. So let's look at, we're not going to start with given on these ones. We're going to start with what property do I have? Do I have congruent segments? No. I have that hi, the length from h to I, plus the length from I to j is equal to the length all the way from, I'm sorry, all the way from h to j, but in here it's written a little different. It's hj equals hi plus ij. This is the segment, addition postulate. And you can look this up, but this is from chapter 1, section 2 when we learned about this. So now that we know this postulate, we can use it in proofs. Now after that, all of the statements are already here. You just have to explain what reason do I have for putting these here. So how did I know that hj was 7x minus 3? Well, it's given to me in this picture, right? See that? So what I did was I used the substitution property in order to take what it was equal to as an expression and plug it in for the length of hj. So the second line is going to be the substitution property, and again, it's of equality, just because, as you'll see, we also have properties of congruence that we'll be using. And then you're going to now it's just an algebraic proof. You're going to maybe add like terms, and then you might use the subtraction property. Now this one, for my statements over here, I did not put simplify between each one. So you'll have to just skip over that, or you can add extra lines to the proof if you would prefer that it be there. So let's see, I added like terms. That's how I got to the next step. So you have to kind of play detective and figure out how did I get from one step to the next. So I added like terms. Then what did they do next? Let's see, we have a 7x. The minus 3 is gone. Oh, they added 3 to both sides. So that's the addition property. Let's just use it as prop of equality. And then finally, I have 2 more steps. Then I had to subtract 5x from both sides. So I used the subtraction property of equality. And then finally I divided both sides by 2. So again, all of the work is done for you over here on this one. You need to fill in the reasons that you're allowed to do that. Number 10 is very similar to this, except this time we start with the whole angle is angle PQR, and that is formed by adding the measure of angle PQS plus the measure of angle SQR. So we'll start with not the segment addition postulate, but the angle addition postulate. And then from there you'll fill in your reasons for being able to do very similar to number 9 after that. For 11, 12 through 14, you're just going to write if this is the transitive property, the reflexive property, the symmetric property. It'll be one of those ones. And then there's just a couple questions at the end to complete. Number 15 is a multiple choice. In number 16, the statements are given over here, or the reasons are given, and you need to complete the statements in order to finish up this proof. All right, well, please let me know if you have any questions. Have some fun with this one, and I'm happy to help if you get stuck. Thanks a lot and have a great day.